two particles, mass of m, let L by 2, L by 2. I'm going to swing that both will describe same radius. This will be what is the angular momentum of this? First of all, you have to ask questions. So where is omega? How omega? Omega will be upward here. I want the angular momentum. So what is the angular momentum here of this? It's a light rod. Angular momentum. So you are going to take like this. This is R bar. This R bar. This is V bar. R cross V. You curl fingers. I think by seeing not possible. By seeing not possible. So what you should do for this? You should take help of your arms. That fingers is what you have to take it here. With the help of that weapon, you should predict how the angular momentum of this dumbbell will be. It will be constant, but what about the direction? This is length L by 2, L by 2. This is omega, direction of omega is shown. This one. The L1 of this will be in this direction. Now what about L2 of this? L2 of this will be in this direction. This is a second particle, this is a first particle. Length are same, okay. Length are different also if you want, okay. No sir, like I'll change length. Okay, no problem. Do it, nothing to do. Or L1, L2, length of the rod. Then how the angular momentum will be directed? Will be in this direction. Will I agree? No, again, when the bobs come here, so when they come to this position, the rod, I'll show it. This will be much easier for us. Huh? Diagram will be very neat. Now look at this. How omega and they're moving in a circular path. There's some neat diagram I'm giving. And let this length R1, R2. Different length also you can pick up. Need not be same length also. There L1, L2 I took. Let me take R1, R2 here. There's a mass is M1, M2. How L bar will be directed? Here L bar will be directed in this direction. So now how do you can say R bar, V bar, R cross V, curl fingers. R bar you're going to measure like this. And V bar is into the plane. V bar, you take pen, you take the pen, don't keep vertical, keep it inclined and try to rotate. And look at the tip of that pen. Somewhere at, not at midpoint, you hold it somewhere here and try to rotate. So what happened to the upper tip and lower tip? They discuss circular motion. Please don't see video. I'm telling this one. You should hold pen or pencil. You have to do that. There's no other way. You just look at me, then gone. Okay, do that. And you assume here one particle, So both describe circular path. No? And when it is rotating here, you see that one. R bar will be like this. R bar. V bar into the plane. So then curl fingers now. So hold it with the left hand. This is R bar. This is a V bar. R cross V. Thumb will be somewhere in this direction. Similarly for this one. So how L1 bar here will be. You might have swinged many times the pen At all the time, L1, L2 will be in same direction. So how to calculate the magnitude? Again, define the R1 bar. So if I define this theta, so as rotating with angular velocity, so calculate that linear velocity and define it. Now look at L bar and omega. Are they in same direction? Need not know. No. The problem will become more interesting if I call O1 about O1. How it will be angular momentum will be along omega bar, but this L1 will not be along omega bar. If you calculate angular momentum about O1, so this should be the perpendicular, and this is the velocity. Or here I think I can show very clearly. This will be the radius vector, and this will be the velocity. Then in that case, how angular momentum will be along omega bar. So here shall we put LO1 will be parallel to omega bar. Whereas L1 is not parallel to omega. I think the direction itself is showing that one.